We are all accustomed to thinking of solutions as mixtures of a substance dissolved in water. But in fact, the meaning of the term solution is broader than that. Perfumes, antiperspirants, the air we breathe, the alloys we come across in daily life like steel, brass and bronze are all solutions. The utility or importance of solution in life depends on their composition. Body fluids are examples of complex liquid solutions containing many different solutes like electrolytes, sugar, urea, oxygen and carbon dioxide. The importance of the concentration of solutions can be seen from the fact that any change in their concentration can have a significant impact on the living system. For example, 1 part per million or 1 ppm of fluoride ions in water prevent tooth decay, while a concentration of 1.5 ppm causes spotted tooth. And any concentration at and above 4 ppm becomes toxic. Therefore, sodium fluoride is used as rat poison. Intravenous injections are always dissolved in water containing salts at particular ionic concentrations, so as to match the blood plasma concentration. A solution is defined as a homogeneous mixture of two or more chemically non-reacting substances whose composition can be varied within certain limits. A homogeneous mixture is one in which the composition and properties are uniform throughout. In a solution, the component that is present in a smaller quantity is known as the solute or the dissolved substance. The component that is present in a larger quantity is known as the solvent or the dissolving substance. The solution has the same physical state as the solvent. A solution containing only one dissolved solute in a solvent is called a binary solution. Depending upon the physical state of the solvent, various types of solutions that can be formed are a solution in which a gas is the solvent, and a gas, a liquid, or a solid is the solute, is known as a gaseous solution. For example, air is an example of gas in gas type of solution. Chloroform mixed with nitrogen gas is an example of liquid in gas type of solution, while camphor in nitrogen gas is an example of solid in gas type of solution. A solution in which a liquid is the solvent and a gas, a liquid or a solid is the solute is called a liquid solution. Oxygen dissolved in water is an example of gas in liquid type of solution. Ethanol dissolved in water is an example of liquid and liquid type of solution, while glucose dissolved in water is an example of solid in liquid type of solution. These liquid solutions occupy a special place in chemistry, as most chemical reactions take place in solution phase. Similarly, a solution in which a solid is the solvent and a gas, a liquid, or a solid is the solute is called a solid solution. A solution of hydrogen in palladium is an example of gas in solid type of solution. An amalgam of mercury with sodium is an example of liquid and solid type of solution, while copper dissolved in gold is an example of solid in solid type of solution. Out of the various types of solutions we just discussed, the most significant are those that are in the liquid phase. We will therefore confine our study to binary liquid solutions. The concentration of a solution is defined as the amount of solute present in a known amount of solvent or solution. Concentration can be expressed qualitatively as well as quantitatively. Qualitatively, we describe a solution as either dilute or concentrated. When a solution contains a small proportion of solute relative to the solvent, we call it a dilute solution. On the other hand, a concentrated solution contains a large proportion of solute relative to the solvent. This qualitative means of describing concentration, although useful, sometimes leads to confusion, and thus arose the need for a quantitative description of solutions. Quantitatively, the concentration of a solution can be described in several ways.